we can start. I was thinking like a strategy with AI. I'm reading the chat. Well, that's Cesar. What you're saying is the most important thing, and that's what we teach in bootcamp, in all the places that we or in these live streams, places that we provide this content. Is like we are not going to teach you the specific way to make money, infinite money, because that's impossible. If not, we will be all rich, right? We teach really how to like translate an idea that you have about how to write a trading strategy in production. So to think about something and see how we can implement that in Hummingbot with code. I'm seeing that Memento. He's saying that for devs, having an AI that knows Hummingbot details would be good. Yeah, I totally agree with that, Memento. I'm currently working on it and reading a book that I recommend from these guys. It's interesting because this guy works in AI. That's basically why I'm reading it, because I have a big important background in AI, but I didn't have the possibility to work on an AI company yet, since I was hired by Hummingbot. I'm working here for a few years, but my main knowledge is in AI. But reading this book from people that works specifically on AI helps me to understand how they think, how they structure the projects, and so was really good. Yes to AI strategy, spot strategy, momentum trading. I'm wondering, is it possible to have a look into a strategy that works within order book and create market orders like ping pong? Yeah, it's all everything is possible. You need to define what has to be done in the order book to create a market order. Tell me what you're looking for and I will tell you how easy it is. But yes, it's something usually easy. I don't recommend too much like an isolated ping pong. If it's just ping pong, you are like just attached to send one order and then the opposite one, and you can stop trading for a long time. So usually that's not recommended. What you would like to have is certain thresholds of the amount of buy orders without sell orders and match them in order to this behavior, right? Because let's say that you send a buy market order, now the market goes down 50%, okay, then you're going to have a problem. I think that we can start. I will present two ideas and we vote which one do we want. So the first idea, in this case, let's say that we have order book, we have trades. What's the difference? Let's talk a little bit about machine learning. Let's do like a kind of class. So basically we have regression and we have classification. And then let's say that we have also Gen AI. This will be a little bit, for me, not something that we can apply as it is, like an LLM to predict the price, because it's not trained for that. We can use the LLM to reason. That's another training idea that I have. But we need to provide a set of strategies and then decide, based on these informations, decide what's the best path to take. That is not bad, because it's not trained for that, but there is always a randomness in terms of the decision, and you never know if it's the right signal or not. So it will introduce more noise probably, but will let you incorporate a lot of data into it. Probably at some point we can even fine-tune it or not, but yeah. So in terms of regression, I will be like very straightforward. In this case, in regression, we predict a value, let's say. In this case, we predict a value in what is regression, right? In this one, we predict a category, and in this we generate text, audio, images, etc. The only way that we can apply this will be with a structured output that we can use, for example, Pydantic AI, that basically is like a wrapper on top of all the AI models. It uses as a output, a structure output based on pedantic models. So you can say, for example, signal like base side, this will be by, let's say, strength, and let's say 0.8, and blah 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 blah. And if we ask the AI something like, here is, in this case, the flow will be more like, let's say that we start with candles, right? In this flow, we get the candles. Then to the candles, we apply signals, apply trading strategies. So here we can apply, let's say, Bollinger mean reversion, MACD trend following, super trend, momentum, and let's say that we apply a few more. So in this case, the idea will be that this will be like the output. Let's say output, this is what we need to have. And we have the candles. To the candles we apply the trading strategies. And at the end we have a list, and the prompt will be something like, here is a list, here is the current state of the market, information about the market, like, for example, price, support, resistance, etc. And then here is the information of the following trading strategies. Let's say strategy 1, and the Bollinger will say if it's long. Strategy 2, this will be short. Strategy 3, this will be long, and so. And then we say, based on all this information, generate a final signal that determines where the market is going in the next hour. So the output of this will be this final signal, and then based on the signal we execute trade with Hummingbot. Okay, this will be like one of the potential ideas that we can do with this, what will be like Gen AI. What's the chance that this works or not? I don't really know. It's like the only thing that something that we can tune a little bit before passing this to the AI will be these training strategies that will be like a combination of potential training strategies. Well, here will be the LLM part. The LLM part will be like this one, will be like this, and we pass here, something like this. So why I think that this might be interesting, because this will be like a normal trader that basically says, oh, I think that if I mix this indicator with this indicator, this will happen. This will be something like that trader that will have certain accuracy and so, but will be able to have information of a few different things. How to fine tune this, I don't really know. So that would be like more like trust and hope that this works, because the LLM is not meant to predict prices or predict something. It will be more like a way to take decisions based on potential scenarios, but will be something a little bit random, just to say. Regarding to the question, this works for TradeFi. Well, Mike already answered. I saw in the reported things that there were a few people using interactive brokers. So there should be a fork of Hummingbot that uses interactive brokers. Then we have the approach of regression, right? In case of regression, we have the chance to predict a value. So we need to, in this case, like build a data set. So we can start from different data sources, right? Usually this will be time series. So the models that we can use here can be like LSTM, GRUs. I think the transformers will also work. And we have obviously the classical machine learning that we can do, like XG boost, regressor, random, forest regressor, and so. But there is a problem here that usually here we try to predict the price. That's for me something that doesn't make too much sense, because predicting a price that is not normalized and all that stuff, and it's like I'm predicting the price in what time horizon. There are a lot of things here. I don't want to spend time talking about this too much, because it's like I will not pick this type of machine learning technique to solve this, to trade this. It's like I rather prefer the Gen AI approach than the regression approach. What I will pick that this will be like a little bit more interesting is the classification approach. That, let me show you with the graph what it looks like. And this is based on the book that I always mention, that is this one, The Advances in Financial Machine Learning. This book uses the classification approach that is mainly focused on the triple barrier method, that our design of the executors also respect that triple barrier method that Marcos López de Prado presented here. So the triple barrier method basically will be doing the following, right? Let's say that we have the market in these conditions. So what we are doing is putting triple barrier. This is like the triple barrier. And basically what it does is, this is like a labeling technique. The labeling technique will help us understand what's the actual output of the signal. Let's say that I'm labeling the current observation. At the current moment, we are seeing like the values that we have for the order book, let's say, and for the past trades. Let's say we are going to provide the past X trades and the order book. But in this case, we don't care about that information. What we care is that at this timestamp, we are labeling the observation, and if the market reaches this barrier, like the top barrier, we classify it as 1. If it reaches the lower barrier, we classify it as -1. And if it reaches the vertical barrier, we classify it as 0. Yeah, in this chapter of bootcamp that I'm explaining some directional trading, I'm showing this triple barrier. So let me paste this. If it touches like this barrier, this will be 1. If it touches this barrier, it will be -1. And if it touches this barrier, it will be 0. For each observation that we have in our dataset, we're going to apply this triple barrier method and determine the next potential output. And what we have there is like, imagine that we have, let's say that we have only candles. Just to simplify, let's start only with candles. So let's say that we have timestamp, open, low, high, close, cap, and trades, BB, length, MACD. At the end of this, we are also going to have a label that this is the column that we need to calculate, right? So let's say that we get this first timestamp. Let's call it this timestamp like T1. We compute this for this T1. The output is, let's say here, T1. We don't care about this, but at the end, the label is 0. Let's say that we have this T2, that at the end of this, let's say that we build the triple barrier here, it reaches here. This will be like the 1, right? So in this case, the T2, this will be 1. Well, and obviously that we have, besides the label, this will be our data set. This is a data set that we need to build. What we do after we label all the observations, first is like we need to actually pass, before doing this label, the label is independent from the features, because the labeling only checks the close price. Basically, the labeling will do the work of saying, okay, this observation end up going up or end up going down. The other question that you will have is, okay, how you define these barriers? Length 1 or length, like, I don't know, 5%, 1%, 3%, and so. And the method that he uses is the rolling volatility to compute the thresholds that we are setting. So in that case, the thresholds that we are setting are going to be using the volatility. That makes sense, because if not, we don't know what's the right value to set the barriers, and we are trying to predict based on like certain standard deviations. Another thing that we should be doing in this data set is filtering. Is like if we predict all these values one by one, probably the final output will be the same, like all of them will be 0. Marcos López de Parado also says that we need to filter based on, for example, volatility conditions. So only pick observations if the volatility is bigger than this, for example. That's like another potential thing that we can do. And then what we also need to do, normalize the data sets. For example, timestamp. We don't care about the timestamp, because if not, if let's say that yesterday the market went up a lot, okay, probably it's going to use that variable as something that will impact in the performance of the model. And actually it's like doesn't make sense to use a timestamp for that. What we can use instead of timestamp is like a trading session. Let's say that is like we can divide it by morning, evening, and night. That's one thing that we can do. Another thing that we should be doing is normalizing prices. We can't use the price as something, because the data set of the 60K will not work or will be doing nothing for the data that we have right now. So for the prices, we'll need to turns, log. We can do a few transformations here for the prices. Then for the Bollinger Bands, BBP, let's say the percentage that we are in the band, that's already normalized. The MACD, we should also normalize it. Let's say features, normalize. Those are like the most important things that we need to do. At the end, we need to train, test, split, train model, validate performance, pick the model, integrate it with Hummingbot. Potential problems that we can have if we want to do it with the order book to make the prediction, as some of you were saying on the group, this structure will probably not work as it is, like for a classic machine learning model, because we need like kind of a structured data, like all the features has to be like in one row. So options there, if we want to do it with order book, is to compute a few metrics from the order book to include in these columns. Let's say that we can compute the imbalance, we can compute the amount of buys and sells from each side, and start adding those features to the data set. That can be one option for that stuff. The other option can be to use a kind of like a deep learning model that we don't care too much about the structure, and we can incorporate the order book directly. I can do the both. I think that the deep learning, the one that uses the order book and deep learning and all that stuff will be a little bit more complex, because probably today we're going to be focusing on building the data set, and I will need to leave this on a server running. We need to dump the data. Since the order book data is not available, we will need to start collecting all the data, and then based on that data, train our model. Next week we can start like train the model. The bad thing about that is that we are only going to have 1 week of data to train and determine if the model is good or not. The good thing is that should be more like a microstructure thing. We don't care too much about the past history for this. It's more like the current situation of the market. We are trying to predict in a very short term what is happening, because we can't use this picture of the order book to predict what is going to happen in the next 5 minutes, let's say. And we are not guaranteed that it's going to work, this stuff, and all the pipeline of this will work only for predicting based on order book and trades. That I think that is the source of the data. Is like, if you think about candles and everything, those are like aggregations of this type of data. It's not a bad idea to build a model that just uses order book and trades. This path, we can do it. Like the two ways of doing it Pick a machine, classic ML model, XGBoost, random forest. I think that doesn't make sense to use bugging because random forest already incorporates the benefits of bugging. So I think that we should be using XGBoost or random forest, or pick a deep learning model that we can, I think that we can do some crazy stuff, just a neural network, or we can pick a CNN. The CNNs are usually used for computer vision a lot, and basically what you have in the CNN is a convolution between the image that you are like analyzing and the filters that the CNN is developing. So the CNN trains like those filters. And the convolution, I don't know if it's very like math oriented. I study engineering, so I had to do convolutions by hand. But basically, imagine that is the product of two functions, and if the two functions at that moment they match, like the result of the convolution is bigger. So imagine that you have a cross, and in the image there is a cross. When that filter passes through that cross, the value will be bigger because it is matching all the points that you are like multiplying. So what it does is it learns how to identify patterns into the image. So if instead of thinking about an image just as a raw image, we can build this image as each timestamp is one of the layers of our image. That would be, I think, that's something really powerful. But at the same time, it's something really complex, and I don't want to lose you in the path. So maybe it's worth to do something more simple to start, and then open the possibility to anyone that wants to build something more specific. I don't know, guys, what do you want? What do you think? I'm reading the chat. Cesar wants a simpler one. Okay, I like the simpler one. LSTM. Yeah, LSTM is also a deep learning model. Basically, it's for time series. It has LSTM is for long short-term memory. It's really interesting. But I think that at this point, I don't know if the transformers will outperform this. The thing is that transformers are usually trained for text. But I saw that in high phase, there are a few time series. High phase, they are like time series models, time series forecasting. So maybe the transformers are already better than the LSTMs. I think that we can start with a basic model for this series. I think that we can start using like just the candles in 1 second. Let's try that. Let's try to build a model that uses candles in 1 second and predicts the price in the next time. So we stop talking and we start implementing. It's going to be a model for Bitcoin. Predict Bitcoin price in the next 5 minutes. Getting 1 second candles data is easy. Yeah, obviously, using Hummingbot is really easy. So let's start playing around and then we will see. Let's start research notebooks. Let's call it Bitcoinator. Okay. So the first thing that we're going to do is to download the candles. So we need to download the 1 second candles. So in order to do that, we run that cell. In order to download 1 second candles, we need to use Binance, because Binance Perpetual, it doesn't have 1 second candles. Trading pair, BTC, USDT. Let's start with 7 days. Low as the data, the easiest to compute things. Then when we are going to put all the pipeline into production, let's use the more time. Let's start with 3 days, easier. Await club dot get candles. This will be connector name, trading pair, interval, days. Get candles last days. Get candles last days. Last 3 days. Let's run it. 3 days, because as we are going to manipulate the data a little bit, we're going to apply transformations and everything, and we don't know exactly what we're going to do. It's better to start with less time. So it's like all the transformations are like easier at some point. This should be a very great feature, like this amount of volume. And the good thing is Binance provides us in the candles the volume traded separated between buys and sells. If we have the data of when the trade was executed, the amount of base and the amount of quote in a second basis, this is not too different than just having the raw trades to use. Just to say, like a healthy aggregation. Core Mister says, do you need a premium API to get second data? No, you just need to use Hummingbot. This library is Hummingbot. Just to explain you the interface if you are new to Hummingbot. With this, I can put like candles here, candles equal to this, and I will have the candles. But I know I was dumping them in the cache. That's why I didn't do that. But if you expect the club, let's put candles cache. So if I get these like Binance, BTC, USDT, 1 second, I get these candles. So let's call BTC candles. So if I put BTC candles dot plot, see the magic coming. The magic didn't appear, but this is a problem of PyCharm is really bugged for Jupyter notebooks. That's why I usually use Cursor. As you can see, the data is at second level, and we have the 3 days that we were looking for. CoreMeister uses the Hummingbot terminal, but this is something that I created this year. I mentioned that you will probably face a few issues with this repo because I wrote this repo in 1 month, just to say. The main idea is to provide a way for Hummingbot users to make research for their strategies, but it's not a core repo of Hummingbot. So it has maintenance because I use it also, but you're going to find it here. This repo is Hummingbot quant.zao. You need to clone it and run the commands here. The last live stream, we explained how to do the deployment, how to use it with Docker. It has an automated module of tasks that lets you schedule tasks and run automated things. It's not like a proper task orchestrator, but I think that is good enough. I'm exploring a few more. I call it a task orchestrator, very simple. We get the data. This data is at second resolution. As you can see, PyCharm is really bugged to filter because this is like 260k records to show in a notebook in a graph. Probably it's a lot of data points for PyCharm. That is very bad at notebooks. What data we have available? We can call BTC candles that data. We can visualize the data set. As you can see, that is, as I mentioned, every second we have the data. We have the open, the high, the low, the close, the volume, the quote asset volume. This is where it's interesting to understand what data is available to see how we are going to transform it. Quote asset volume is really important. We need to normalize it, yes. Then the number of trades is also important because here we can identify, is the volume made with a lot of trades or is the volume made with a very small trades? So for example, in this case, in this second, there were 16k traded, but with 124 trades. In this case, were 47k traded, that is like a bunch of times more, but with much more less trades. So yeah, this is like probably something that the machine learning model will understand later on. Then we have the taker by base volume, and then we have the taker by quote volume. So what we are going to use is this one. We are going to discard this column. But well, let's add another notebook for this feature engineer. Let's call it feature. In this feature, this call it like 00, rename to 0, download candles. 1 feature engineering. Arakel says the quant.zao is a Jupyter personalized version to easy integration with Hummingbot. Yeah, it has in these research notebooks, you have all the things to do analysis, and you can also deploy bots from the notebooks. That's something that is really cool because we have a backend API client, and I created another repo that is backend API, that is a fast API server, where you can say run this bot with these controllers, and as it's an API, you can query it from anywhere. And I added a backend API client here, so in the Jupyter notebooks you can do some analysis and then deploy a fleet of bots. So yeah, it's really cool. I'm very happy with that. So the second notebook that is feature engineering, let's stop this one. The candles, let's stop it, yes. Now let's move to feature engineering. In this one, what we're going to do is to, instead of download the candles again, we are going to load the candles from the cache. So the first thing will be initialize the club, and now let's put club load candles cache and the root path. This is going to load the candles from the cache. As you can see here in data candles, we have these candles downloaded that we just downloaded. So now we can start working with local data to make the things more straightforward. Because imagine that you have a problem in the notebook, you need to restart everything again, you need to download all the candles. So it's like at some point you would like to cache the data and start working with local data. Now if we load this again, let's remove the plot. If we go back here, we end up having the same data that we had before. Now let's start transforming the data a little bit. First, let's add the triple barrier. I think that we need a triple barrier first. So the index PD to date time, yes, this is already done, so it's the same. Then if std span, then the target is the perfect. This TL is in seconds. That's an important thing too. What we can do is to, from core backtesting triple barrier method, import triple barrier method. This returns a df. So df with tpb triple barrier tvm, let's call it. This will be triple barrier method, and here is df TP, let's put it 1.0, SL, this is like the standard deviation, I think. One standard deviation down, one standard deviation up. Let's put 2, because it's 1 second candles. Then we have the TL, that is in seconds, as we saw before. So we said that was 5 minutes, so 5 minutes times 60 is 300, right? Yes. So 300, and then we have std span, let's put 100. Trade cost, this is interesting because we can also estimate the trading cost to see if it was positive or negative. We put 0.006 because the maker is 0.02 and the taker is 0.004. So we can go here and understand the code together. Usually, if you are not a coder, you are more like machine learning guy and all that stuff, you are not used to debug. But I strongly recommend you to learn how to debug code. If you learn how to debug, you're going to understand much more what is happening. And in this case, for example, I have this method and I really want to know like all the steps that are happening. Yeah, I can read the code, but if I'm reading the code while I am debugging, I can inspect the variables, see the transformations, and all that stuff. Let me show you how to debug. So here we are in this level. So as you can see, it's going to assign the index in this part that is already assigned, so it's going to be the same. Then says if std span, that in this case we already assign it, there's 100. We're going to enter here and we're going to add the target column to there. So if we inspect the data frame now, we said that the target column was added. So as you can see, it's showing 100 records. The first ones are NaN, mainly because what it's doing is the rolling of 100, and the first 100 does not have rolling. That's why after the first 100 we can see other values, right? So the next step is to add the time limit. So the time limit, what it's doing is saying to this timestamp, add the next amount of seconds that we put 300. So it should add like 5 minutes from that timestamp for the time limit. So if we pass the next one, time limit, we open this again, we will see a column here, that time limit. Let's move it here. Time limit has to be 5 minutes, and as you can see, it's perfect. From 56 to 01 is 5 minutes, so it's working cool. And then we are dropping the ones that the target is NA, so the first 100. So if we run that cell, you will see that now we don't have columns with NAA targets. Then we have this method that is apply take profit stop loss on time limit. Here we have a problem, I think, because we didn't add the side column. So we need to add that first before we run this. So here it's going to fail because, yeah, that is where it's failing, I think. Then it's failing because we need the side. As you can see, key error side. The thing about the side is that this triple barrier works for long and short. So it's like to understand where is long and where is short, right? Let's add a column that is df is equal to df side is equal to 1, and let's write it again. Let's go here. So events, we have all these things for the events. If the take profit is bigger than 0, we are going to assign the take profit and the stop loss and so. So this is only for calculating the take profit. As you can see, remember that I mentioned how the take profit was computed in this method. It was using a standard deviation. So the target is a rolling, and the standard deviation of the rolling of the last 100 records of the percentage of change, so it's the returns. If we see the events df, we have the target, the side, and the take profit and stop loss are these two series. Depending on the time, are going to be different or not. This value is 0.03%. So it's very low. So that's the first thing that we need to adjust. But this is like basically what we are going to do. Adjust everything. We're going to start with, let's put like 4 standard deviations. Let's start over. Let's reinitialize the environment. Okay. Let's run it now as it is. And let's see the output. Here we are like doing the triple barrier for all the observations that we have in the dataset. So at some point we should be doing the filtering, as I mentioned, to only take into account, I don't know, the ones that has X volatility and so. Oh no, something happens here. So let's run it with the first 1000 observations. This is not necessary, I think, because this was when I didn't have the backtesting. Let's try it again once more. When this is important, when you are doing a change on a file that is in the in here, for example, in the repo, that is not in the notebook, usually you need to initialize again the environment. df with tbm describe. These are the columns that we care, like to understand a little bit what happens. Well, we have a very bad return in average. Let's understand a little bit how these features are computed, like these columns. The actual return that we have from the trading activity. We are using the close time, and we divide it from the close time of the first time, and we multiply it for the side. So this only takes positive values for the actual side. And then the real class is if the return is the sign of the return minus the trade cost. So if we see that the returns, the median of the return is negative, it's like almost all the returns are negative. Let's add a new one here that says df with tbm dot real class dot value counts. So we have 776 shorts and 125 longs. And then we have the close type. This is also the other one that we really need, that is the actual value. The thing is that this real class incorporates the value of the trade cost, and this one is not incorporating that, it's just incorporating the 1, the -1, or the 0. So well, it's like we need to define what we're going to use for training our model. So let's say that we are using the real class, or what we are going to use. This is the real class. They only have 1 or -1. This will be like no, it's not right, because we should have the 0 actually. Yeah, we need the 0 because we only want to predict when it's actually 1 or actually -1. Let me see the chat. What backtesting framework are you using? Hummingbot Zone? Yeah, I'm using Hummingbot. And Raquel says the triple barrier strategy. Now, it's not a strategy, a triple barrier. It's like a labeling technique to identify if the final output is going to be 1, -1, or 0. And then Clouds World says, do you recommend something different to PyCharm when working with Jupyter notebooks and also being able to debug? I think that you can do it with VS Code. Actually, I like much more the Jupyter notebooks experience in VS Code than in PyCharm. VS Code or Cursor is the same. But I don't like the debugger of VS Code, so I use PyCharm. I use Jupyter in VS Code and the debug works okay. Yeah, the debugger works okay. But I like much more like the experience of JetBrains, so that's why I use PyCharm and I don't use VS Code. Let's replace here, instead of this TP, let's put 1, -1, and TL 0. Okay? The thing is that we have like a kind of problem. Let's put 5, because I think that the fees are very high for this second trading. Probably it's better to do it in spot for Bitcoin for this. Let's add like 200 records here. Let's start over. No, wait. I need to install a few libraries in order to do, so let's continue with 1000 so we do it faster, but I will probably need to install a few libraries in order to work with AI. I don't know if they are installed. Scikit-learn is installed, let's see. So yes, we have scikit-learn, nice. DF with TVM, we need to drop a few things to do the training and also transform a few columns. So these are the columns that we have. We need to define like the strategy to do all the transformation. Yeah, probably I can move now to VS Code and ask Cursor for doing the pipelines and all that stuff. This Cursor, let's run this again. Load the caches, load the data, and let's put that columns. Oh, well, let's see this. Okay, these are the columns. Let's say to the AI, the data frame df with TVM has the following columns. I want to trade a machine learning model to predict the price, the model where the target is real class that can take the value of 1, -1, or 0. Remove close time, close type, or close type was the one that we need. Close type is the one that we need. The target is close type. Close type, standard, use standard scalar for the numerical values. Okay, these are the things that I want to do, that I can do it by myself, but if he wants to do it for me, that would be better. Let's see what he's doing. And then df process it, drop index and place true. That's also comes to remove, perfect. Then we are in the percentage change, perfect. We drop in the price columns, perfect. We compute the volume by volume ratio, perfect. We drop the taker, perfect. We drop the NA, excellent. And the standard scalar, feed transform. Well, I think I did everything that I asked for, so that's really cool. Reset index equals true. There is another like drop equal true. Let's run this cell by cell so we can see how was the state of our data frame on each step. df processed. Okay, we still have all these columns. take profit time, stop loss time, TL, side. Okay, now looks better. Now we have the final data set that we want. We can add a few more features. So let's ask the AI. Copy is a parameter deep equal true. No. I think that the data frame already has a copy incorporated that creates another copies like all the memory. So it's like a new object. Now I would like to add a few features to the data set to make the prediction using pandas TA. Here are some examples of how you can add indicators. So let's go to the MacDBB. Okay, let's add a few more features and then we're going to drop this data set. And now we're going to go to the last notebook where we're going to be starting doing the building the model. This will be first, I think. I think that is here. Let's restart this. Oh, this one is nice. This numeric columns instead of. I like this. Okay, well, let's try now. Restart. Oh, nice. Well, now we have this data set and we have this close type. Well, this will be like our features data set. The next thing that we're going to need is to create a AI model that will let us predict what is going to happen next. Now I want to do a train test, or probably we can dump this. Let's keep the index. I want to store this. We have a feature to store. Dump dumples cache as path shown df to parquet. Let's dump it. Let's call it like data. It will be like data. Let's add a new one that is like features df. Features df. Features df. And this is going to be like BTC candles at. Let's remove the name. Instead of BTC candles, I call it just candles. Like that. And let's call it candles dot connector name, trading per interval, parquet, by arrow, snappy. Let's see if this works. Okay, now we have this. Perfect. How come time is not a feature to predict? Price with relative distance to the moment to predict must be useful, right? Yeah, but it's like the timestamp is sequential, so it's like one after the other. And a timestamp from the past will be totally different to a timestamp of right now. It's like a sequential number. So the timestamp as it is not something useful unless that you are transforming it in some way. Like hour of the day, like fraction of time, like what series or what, if it's a New York Open. Well, those things might evolve, might be interesting. For me, the timestamp as it is does not make sense to use it to train, because if it's using that variable a lot, it's like the timestamp will not be repeated in the future. So it's not something that makes too much sense. But if you want to use it and you find it useful, do it. Let me add the last notebook. This will be to modeling. So let's run this. Comes up, yeah. So let's load the candles just to have them. And now let's load the df with features. Will be equal to pd.read pandas as pd. Let's do it this a little more clean. Let's call it like okay. How so? Let me restart this again. Features df. No, so yeah, that's the problem. DS processed is what I need to dump. Okay, now let me restart this. Okay, oh fuck. Pack. We have the dataset here. So now let's open a new chat. Let's say I want to train a random forest with the df with features data frame that is already the target column is close type that has the value 1, -1, and 0. Please generate the code with, I don't know what is good parameters for it, but let's say. And then this is something that is really cool for us, is that I already coded an integration with Aptuna. We have that integration. We will be able to test a bunch of different parameters for the model to see what's the best fit for the prediction. But at the end of the 3 live streams, we're going to end up with a good outcome. Does 0 mean that the time limit was reached on the trial method? Yeah, correct, Clouds. That's the right point. If the barrier that was met was the time limit is 0. That's really important for us. Why? Because it's like the signal wasn't significant enough to take a decision. So at the end, what we want to predict is only when it's 1 or -1 to understand what is happening. So usually what we can end up doing with this type of a strategy is we can even do nothing if it's like 0, or we can run like a kind of market maker if it's 0 and do nothing. If it's 1, we can create a long grid, let's say. And if it's -1, we can create a short grid. That's like options that we have. Let me see what it's saying here. Wait. Use plotly graph. In Humming, are we fixed on using time bars, or can we change the bars to something else like dollar bars? That's a very good question. And right now we can only use time bars, but it's not difficult to build the dollar bars or volume bars. Actually, that's what the Marcos López de Prado book says, that we shouldn't be using time bars, we should be using volume bars or dollar bars, because the returns have a much more like normal distribution when using volume rather than using time. I think that there is a graph here. So, yeah, here is the one that I was saying. The dollar bars and the volume bars are like these two, and these are like the tick bars, like I tick by tick. So it's like you can identify much more like the bubbles with that. At the same time, I think that this is good. It's like we are building a model for short-term prediction because it's like 5 minutes. I think that we should try to build 3 types of models, one like for short-term, one for mid-term, and one for long-term. And I think that we can make much more yield for using a mid-term to long-term model, because we can generate yield by doing like market making, or by you can call it market making, or we can call it like HFT, for example. If some of you check my Twitter, I upload a lot of videos, well, not a lot, but a few videos showing how my bots trade in HFT. In a market that is 0 fees, you generate like 0.3%, 0.4% daily by just matching P&L, like buy, sell, buy, sell, buy, sell, buy, sell, buy, sell. If you then combine that with a signal in a long term, you can make a lot of money, because in the meanwhile, you are generating yield by just the price movements. So if you can add to it the ability to have a prediction, it's like as much time you stay in the range, more yield you generate, and you can at some point close the trade later on. But that's something like interesting to try. So I think that we can spend like 3 or 4 weeks working together on this. A Discord channel for the ones that are interested. Feel free to say if you are interested in that. Let's see what happens if we run just sell that cursor. This is a feature importance. The target is the volatility, and it's not the real target. Yeah, you know what is happening here? We need to remove the 0 because we don't want to predict the 0. We just want to predict the 1 or -1. Or we want to predict 0. The thing is that I think that it's really imbalanced, this. Let me see. It's very... The first thing is that I only dumped 5,000 records for this because I did a transformation just to validate the flow. So the first thing is that. The second thing is that it should be really imbalanced. Maybe I have a lot of zeros, so let me see. df with features, close type, value counts. Yeah, so you can see we have 3,000 zeros. So that's why it's predicting the most of the predictions are 0. So that this is a problem of the imbalance. So one thing that we can do is drop the 0 observations, or drop up to the point that we have only the same amount of values as 1 or -1. That will be another thing. The other option will be lowering down the thresholds, because here in the model in feature engineering, I put like 5, so we can move it to 4. So we have like more ups and downs. So this is like the part of being more like a scientist, to understand really what is happening here. I think that we can close today's session. So I think that was a good streaming. There was a lot of interaction with the audience. So thanks for being there, supporting this initiative. Let me check the chat. I'm going to upload this. And Carlito, let's create a group, a channel, or rename the live stream channel to live stream AI Hummingbot, whatever. And yeah, let's continue the conversation there. I will upload the code into a PR. So if someone wants to continue or do some research to contribute for the next live stream, feel free to do it. And the next week, we can continue working on this and setting up an infrastructure, because at some point we need to do continuous training. Well, if we spend 1 month, we can end up with a solution where we collect data in a recurrent basis, we generate features, and we do continuous training and deploy a lot of models. That would be fucking crazy to do it all in a live stream. And you will see my powers of AI there. So let me read the chat a little bit before we close. I've been doing that and market making money non-stop. Thing is, I need to use options data to predict volatility. Yeah, if you were using the script that I have for market making, it makes a lot of data, a lot of money in the ups and downs. But the thing is that if you can combine that with a signal that will tell you the market is going to go, it's like, is the prediction is a 0 or is a 1, you can enter in that market and start doing like market making while you know that the signal will help you go into that way. Sometimes I get stuck with adverse inventory. Yeah, managing inventory is like the most interesting thing. You could make the individual trees in the forest weaker. Yeah, that's really interesting. Just to explain, well, I stopped now, but I used to teach machine learning in the university. So if you have questions about how the model works, I can answer that. Just to give an overall context, the trees, the machine learning models that were using trees, the original trees, they have a problem that is called overfitting. Why? Because the way that the tree works is like you start with a bag of observations that are 1 minus 1. Let's say that is 1 or minus 1. And what it's going to do, the tree is going to look for the variable that reduces the entropy the most. You can have a Gini entropy. Well, there are different types of different ways to compute the entropy, but entropy is like the disorder of information, let's say. Sorry, because I'm not English native, I'm speaking Spanish, but sometimes the words, I don't know what is the right word. But basically what you do is to say, okay, how can I reduce the entropy? And entropy is like having things mixed. So if we want to reduce the entropy, is like how we can start from this node and end up with 2 nodes that the classes 1 and the classes minus 1 are more separated into these 2 nodes. So these 2 nodes have less entropy than the initial node. So what it's doing is saying, okay, if there is 1 or minus 1, I want to find something that divides the 1s and minus 1 as much as possible in this step. So you end up cutting with a variable. That's why, actually, this is more like for mathematical perspective, for me it doesn't make sense to standardize the value if you are using a tree-based model, because it's going to find a way to cut that to 2 different places. So if the value is standardized, it will cut for like a vertical thing or horizontal, whatever you want to see that in your mind. But it's like, that's why it doesn't make sense too much to standardize it. But well, what it does is it divides, and at the end you end up with leaves, the end values that when an observation enters, cuts everything with these rules, and then says the value is 1, the value is minus 1, by a prediction of how many classes are inside the end node, depending on the cuts that the tree has. What happens to that is that it leads to overfitting, because you have a sample and you cut the sample and you said everything from this sample will be repeated in the future, or this is a distribution and you don't know exactly that, and ends up overfitting by something that cuts the thing maybe a lot, and sometimes you are missing some opportunities of cutting the sample for other variables, right? So solutions for the overfitting there were, the first one was bugging, that basically instead of putting all the sample at once, you can do a bootstrap of the sample. A bootstrap is like, imagine that you have 10 observations, you pick like the first 3 and the last 4, then the next one, and you train the model. In the next one you pick the 3 and 5, and it's like you bootstrap the sample, and based on that you generate different trees, and then based on the majority of the votes of each mod in the internal model, you have the final output. And the last and that was like a very good thing to improve like the overfitting of the models. But the last, the random forest is similar as debugging because you have the bootstrapping of the sample, but as an extra thing, you in each tree that you train, you don't use all the features that you have. So imagine that you have 100 features, you limit the number of features that you are using to pass to the tree. So imagine that you put at maximum you can use 7 features. If you are using 7 features, it's going to pick from the 100 in a random way 7 features and then training the model. In that case, if one variable is really important or is usually used to divide the tree at the beginning, it's not used all the time. So if you want to make the trees weaker, you can reduce that variable, that is how many features you use on each split. You may want more general, so you can use stratified sampling to put more samples weights on. Yeah, but the thing is that we're going to keep the 0, yes, we're going to keep it, but we can find a way to balance it by improving the thresholds that we are using to do the sample. I think that's all. I hope that you like it. I will push these changes. Well, thank you very much and see you on the next week. Bye bye.